Am I audible? Hello, Aditya, Atul, Praniti, Dev, my screen is visible to you and am I audible?
Yes, sir.
Yes, sir.
Okay, okay, thank you. So, in the last lecture, we have solved certain problems based on the root locus method. Okay, we have seen how to calculate angle of departure or arrival. Okay, so I request you all please solve certain problems based on the root locus method because whenever you are if you solve variety of problems you will get a variety of clues. Okay, so I have taken a sample problem so that you can solve any kind of problem based on root locus method. Okay, so the one small point is remaining in unit 4, that is what will be the effect of addition of the poles and zeros onto system stability. So with the help of example, I just try to explain you. Okay, so you just use the heading effect of addition of pole, effect of addition of pole and zero into the system. Okay, so first part we will take, okay, addition of pole, addition of pole. Okay, so what is the effect that is adding up pole or zero into root locus? So the main uh, effect is that if you add a pole or zero to the system, then what will happen? Your root locus branches in a S plane, either to the left hand side of the S plane or either to the right hand side of the S plane. So that we have to see whether by adding pole, whether it is they are shifting toward right hand side or whether they are shifting towards left hand side. So by obtaining this information, then we can directly comment on the stability. What is the effect of addition of pole and addition of zero? This is the actually this part is related with the design purpose or the stability determination purpose. Suppose if you have solved the system, analyze the system, it found that your system is unstable, then how to make your system to be stable. So for that purpose, we may use a addition of pole or addition of zero. So that is the basic purpose behind. Okay. So let's take an example. Let's say we have g of s into h of s. Okay, open loop transfer function say k upon s into s plus 2. So this is the first case we have considered. So here, basic example we have taken k upon s into s plus 2. So you just sketch a rough root locus of this given transfer function. So first of all, identify number of poles. So here p is equal to 2, z is equal to 0. So therefore, as p is greater than z, so therefore number of branches must be equal to number of poles, and that is equal to 2. Okay, and the poles can be located at s is equal to 0 and s is equal to minus 2. So I just draw a rough sketch of this given example, sigma plus j omega. So one pole is located at s is equal to 0, another pole is located at s is equal to minus 2. Okay, so this could be your s1 or s2. This could be your s1 is equal to 0. Okay, then, in short, you just try to sketch a rough sketch of root locus. So as two consecutive poles are there, second step is that find a part of root locus and non-root locus or existence of root locus on the real axis. So if you divide this section, okay, so beyond this e plus z for this section is odd. Therefore, this will be the part of root locus. Therefore, I have darkened this section. Beyond this part, if you do, so P plus Z is 2, so therefore this will be part of non-root locus. So after that, as two consecutive poles are there, so therefore there should be existence of one breakaway point here. Okay, so this will be your breakaway point somewhere here. I am not going to calculate what rough sketch. Then as p greater than z, okay, and no presence of 0, therefore both all the root locus branches, that is n, will be terminating on infinity. Therefore we require two angle of asymptotes, and for this system, if you determine the angle of asymptote, so you will get theta 1 is equal to first one is 90 and theta 2 is equal to 270, like this, and centroid is mitigating somewhere here. Okay, so therefore let's say draw the angle of asymptote. So one asymptote is along, let's say this is centroid sigma, so this is my first asymptote, this will be second asymptote, let's say this will be my virtual infinity point. Okay, this will be second virtual infinity point. So your root locus may start at k is equal to 0 at this pole. Okay, again similarly at k is equal to 0 at, so this is first branch, this will be second branch, they will be meeting together, and beyond this, so that's why this is breakaway point. So it may exit and it may follow to this angle of asymptote, like this. So this is the rough sketch of root locus for this given example. So now the second case we are going to consider here, we are going to add one pole into this system. So G of S into H of S equal to A upon S into S plus 2 into S plus 4. So one pole we have added. So what will be the addition of effect of adding pole onto root locus? So that we have to see. So here again write down the basic information. Here P is equal to 3, then Z is equal to 0. So naturally again P greater than Z. So roots are located at 0, -2 and -4. So again we are going to change the rough root locus sigma j omega. One pole is located at 0. Here is -2 and here another pole at -4. Okay, then part of root locus and non-root locus up to this section. For this section P plus Z is odd, therefore this will be the part of root locus. Then for this section P plus Z is even, so therefore this will be a part of non-root locus, and beyond this it is odd, so therefore this will be the part of root locus. So this will be second step. Then identification of breaking point and breakaway point. Okay, so here is the existence of one breakaway point, and here is the existence of one break in point. Okay, then as there is no 0, okay, so therefore three angle of asymptotes will be there. Okay, so you can determine it. So here we are drawing simply rough sketch. So as three branches, so one branch will be, so three angle of asymptotes means theta 1, theta 2 and theta 3 value you have already determined in the example. So theta 1 is 60, theta 2 is 180 and it is 300. Okay, so somewhere here you will get the centroid and you will get, this will be your theta 1 60 degree, one along this negative axis, theta 2 180 degree, and this will be theta 3, that is 300 degree, like this. Okay, then the root locus branches may start moving like this, and after this point, okay, so one branch may move like this, and another branch may move like this. Okay, you try to sketch. Okay, so these are the two root locus branches, and one branch may move along like. So what is your comparison between this first example and second example? The effect of addition of poles. So as here in this example, we have added a pole into given transfer function. So it observes that, we just write down the conclusion, it observes that, so here in this case, you see these two root locus branches are never approaching towards imaginary axis. But here in this example, as we add a pole into transfer function, these root locus branches are start moving towards imaginary axis. So it observes that as pole is added, as pole is added to transfer function, then the root locus branches start moving towards imaginary axis. So that means what? As the root locus branches are start moving towards imaginary axis, that means in the case of effect of addition of pole, the value of damping ratio zeta, which is decreases. Zeta decreases. Okay, so therefore we just draw a conclusion for effect of addition of poles. Okay, so our first conclusion is that the root locus shift towards imaginary axis. Root locus shifts towards imaginary axis. Okay, so this first point is proved with the help of these two examples. You see, these root locus branches are not diverting towards imaginary axis, but due to addition of pole, the root locus branches are moving towards the imaginary axis. Okay, then second one, so what is this effect? The value of k decreases. Okay, so again we say that, what about the stability? So as root locus branches are moving towards imaginary axis, so therefore the relative stability of the system may get slightly decreases. So you just write down the system stability slightly decreases or relatively decreases. The reason is mentioned here. Then third point, system become more oscillatory. System becomes more oscillatory. Okay, because the reason is that as the value of damping ratio zeta decrease. And last point, the range of operating value of k for stability decreases. The range of operating values of k decreases. So if you determine the range of k for this, your k value never intersect the imaginary axis, or root locus never intersect imaginary axis. Therefore, it will be larger. Here in this case, it may reduce it. So this is the all about the effect of addition of pole onto system. Okay. Then next point, effect of addition of zero. So same examples we are taking here. Addition of zero. Okay, so what is the effect of addition of 0 onto system, G of S equal to K upon G of S into H of S, K upon S into S plus 2. So its root locus is similar to previous one. So P is equal to 2, Z is equal to 0. So P greater than Z. So therefore N is equal to P is equal to 2. Okay. So I will sketch the rough sketch. Sigma J omega, first pole, second pole minus 2, S is equal to 0, S is equal to minus 2. So one centroid like this. So this is one root locus branch. This will be terminating on infinity. This is 270, theta 2, theta 1, 90. Okay. This will be second branch. So this is the root locus. Then in second case, E of S into H of S equal to K upon S into S plus 2, and here we are going to add one 0 into system, that is S plus 4. Okay, so how is the rough sketch of your root locus? So here in this case, you just write down here P is equal to 2, Z is equal to 1. So again, P greater than Z and P minus Z branches which are approaching to infinity. That means one branch can be approaching to infinity. Okay. So we'll try to sketch rough sketch. Sigma J omega. Locate the zeros. One pole at origin, one pole at minus 2, and 1 0 at minus 4. So this will be the 0. Okay, so there should be a one point, breaking point or breakaway point exists in between the two consecutive poles, and one breaking point is exit over there. Okay, so here is break in point, this will be break away point. So one root locus branch may start here, second root locus branch start here, and then over there it may break and it may start like this. Over here again this branch may start like this over here. So one branch may terminate on open loop 0, another branch may terminate on virtual infinity. So this is the nature of root locus for the addition of 0. So what are our conclusion here? Here you see this, the root locus branches are moving straight parallel to imaginary axis, but now they are start moving towards negative infinity. So that means they are moving away from the imaginary axis. These root locus branches are moving away from the imaginary axis. So this is the effect of addition of 0 onto the system. Okay, so therefore you just write down the conclusions for addition of 0. Addition of 0. Okay, so what is the effect? The root locus branches moves away from the imaginary axis. Okay, you just make the change. Root locus branches moves away from imaginary axis. Okay, then second effect is that regarding the system relative stability increases. Then the system become less oscillatory because the value of damping ratio zeta increases, and the range of operating value of K for system stability, it is increases. So these are the simple few effects of adding a pole and zero into the system. So you just remember the key point. When we add a pole to the system, the root locus branches are moved towards imaginary axis. Hence, the system relative stability decreases, the damping ratio decreases, hence the range of operating range of K decreases. Okay, then in case of addition of zero, the root locus branches are shifting away from the imaginary axis. So therefore, the relative stability increases, system becomes less oscillatory, and the operating range of K also increases. These are the few conclusions from effect of addition of pole and addition of zero. So here we finish with unit number 4. If you have any doubt, you can ask. Now, give the next heading, unit number 5, frequency response method. Unit 5, frequency response method. Okay, so here in this unit, basically we are going to study two methods. One is the polar plot method, and second one is the Bode plot method. So before discussing with that, what do you mean by frequency response? Okay. So in the previous units, we have seen the time response. So time response is nothing but what? It is a simple graph of T of t versus time t. Okay, so when any system is subjected with a standard test signal, then the response of the system versus time is nothing but the time response. So here, similarly here the frequency response, let's say this is any system. Okay, then when this system is applied with a sinusoidal input, okay, when we apply a sinusoidal input, then we'll also get a sinusoidal output. We'll also get a sinusoidal output, but the amplitude of the output response is different from the input amplitude. So the frequency of the signal is same. Then such response is called as the frequency response. So frequency response of any linear system is nothing but if a sinusoidal signal is applied an input to linear time invariant system, then it produces a steady state output which is also sinusoidal. The input and output sinus signal have same frequency but different amplitude and phase. So that is called as a frequency response of the system. Then how to plot this frequency response of the system? So frequency response consisting of two terms. So in general we have G of S into H of S. This is the open loop transfer function of the system. Okay, so in order to get the frequency response, the general steps is that you always replace this S term by J omega, where omega is nothing but 2 pi f. Okay, so your first step, how to convert a S domain into frequency domain system. So S will be replaced by J omega. Then we will get G of J omega into H of J omega. Okay, so your system is converted into frequency domain. Okay, then the frequency response is nothing, response consisting of two terms. One is called as magnitude plot, and second one is called as the phase plot. So how to get magnitude plot and the phase plot? Okay, so G of J omega into H of J omega. So it can be expressed in the polar form. We just express this into polar form or rectangular form. So G of J omega into H of J omega. So that can be expressed in R angle theta form. So R is the magnitude and theta is the phase angle. So it will be given by magnitude of E of J omega into H of J omega at an angle of E of J omega into H of J omega. So here this magnitude of G of J omega into H of J omega is called as the magnitude, and sometimes it may denoted by capital M. The notation for this is capital M, and phase phi, and the angle of G of J omega into H of J omega. So this will be represented by angle phi, where this M is the magnitude and phi is the phase angle. So in this way, we can determine from the given transfer function, open loop transfer function G of S into H of S, convert into frequency domain, and in this way we can determine the value of M and the value of phase angle phi. And with the help of this M and phi, we are going to plot a frequency response of any system. So please note down this M and phi. Okay, and where, what do we mean by this omega? Where this omega is called as the input frequency. Omega is nothing but input frequency. That means we can take the, apply the different input and take the different output. So this is regarding the frequency response. Then similar to time response specification, it consisting of frequency response specifications. Okay, so in time response specification, we have peak time, rise time, then peak overshoot, settling time. So these are the time response specifications. So similarly, same can be correlated in the frequency response also. Okay, so in frequency response specification, basically, so I just give you one example of plot of the frequency response. Okay, so let's say frequency response is nothing but it is the graph of magnitude versus omega versus frequency, magnitude versus frequency, and phase versus frequency. So these are the two plots are present. So M versus omega plot. So let's say this is the nature of the plot. Okay, magnitude versus frequency. Okay, so for this plot, how to represent the frequency response specification? So this is the first peak, and corresponding to first peak, we will get the frequency is omega r, and its magnitude will be given by mr. Okay, and this will be your omega c, that is called as corner frequency. Let's say this magnitude is 1 unity, and when your output reaches to 0.707, let's say this magnitude 0.707 times its peak amplitude, then this will be your omega b. So this is called as bandwidth. So this range of frequency is nothing but a bandwidth. Okay, so these are the frequency response specifications. So MR is called as the peak amplitude, or which is also called as resonant peak. Resonant peak. Then corresponding to resonant peak, we'll get omega R. Okay, so this omega R is called as resonant frequency. Resonant frequency. And third frequency response specification is omega B. That is called as bandwidth. Okay, so these are the three frequency response specification: MR, omega R, and omega V, and that can be represented in this figure. Okay, so this omega MR is analogous to the peak overshoot in the time response specification. They are analogous quantities. Okay, so small derivations will be there. So I am not going to derive this derivation. I have already given in my notes. So just go through it. Okay, so I just give you the formulas. So MR will be given by its formula. It will be given by 1 upon 2 zeta into square root of 1 minus zeta square, where this omega r is the resonant frequency, and it will be given by omega r is equal to omega n into square root of 1 minus 2 zeta square. And this bandwidth omega b, so its formula will be omega n into square root of 1 minus 2 zeta square plus square root of 2 minus 4 zeta square, 4 zeta square plus 4 del square. Okay, so these are the required expression for frequency response specification. So I request all of you, please go through the derivations and the standard definition. So these are the very generalized one. Okay, so this is regarding the frequency response specifications. Okay, then we start with the next point, that is polar plot. So please give the heading polar plot and understood it. Polar plot. So what do we mean by polar plot? Okay, so polar plot is nothing but, again, it is a graph of magnitude versus phase plot. So polar plot is nothing but, it is the graph between magnitude versus phase. So magnitude will be given by capital M and phase will be given by phi. So polar plot is the graph between magnitude versus phase phi. Okay, then how to construct it? Okay, so as we have G of j omega into h of j omega, we have expressed it in polar form. So magnitude of G of j omega into h of j omega at an angle of G of j omega into h of j omega. So this will be represented by simple m at an angle phi, where m is given by this, phi will be given this. So m versus phi, that will give you the polar plot. Okay, so therefore polar plot can be drawn between the magnitude and the phase angle of g of j omega into h of j omega by varying the omega. Just vary the value of omega. Okay, from you just vary the omega from 0 to infinity. So this plot can be plotted from simply by varying omega from 0 to infinity. We will get a polar plot. Then how is the rough graphical graph polar plot structure? So it consisting of like this structure. This is the image complex plane. Okay, so this is real axis and this will be the imaginary axis. Okay, and at this complex plane, we just draw a simple concentric circle like this. So I can tell you what is the meaning of this concentric circle. Okay, so this concentric circle indicates the magnitude of your polar plot. It represents the magnitude, and in a simple line, let's say this will be 45 degree, this could be 135 degree, 225 degree, like this. So this line represents the phase angle. So in this way, we can plot magnitude versus phase angle. So this is, in this way, this will be the representation of simple polar plot. So polar plot is nothing but it is a graph from versus magnitude versus phase angle, where this concentric circle represents the magnitude and this lines can represent the phase angle. Okay, measure the angle by using clockwise direction or anti-clockwise direction with respect to reference. So this will be your reference axis. Okay, so this is the simple sketch of polar plot. Then how to what are the rules for drawing the polar plot? Okay, so rules for drawing the polar plot. Okay, so your rule number 1 is that we just substitute s by j omega. Then rule number 2, write down the expression for magnitude m and phi of e of j omega into h of j omega. Okay, from given transfer function. Then third step, find the starting point. Find the starting point. So from where your polar plot will be starting. Okay, so you have to find a starting point or starting magnitude. Okay, so find the starting magnitude. And phase of g of j omega into h of j omega by substituting simply omega is equal to 0. Okay, so your polar plot always start at omega is equal to 0. So polar plot start with this magnitude and phase. So simply substitute omega is equal to 0. That will give you starting point. Then fourth one, where is your ending point? Okay, so find the ending point. Find the ending point. Okay, and ending point you will get simply substituting omega tends to infinity. So start point will be given by omega is equal to 0. You will get start point, that is starting magnitude and phase, and ending point we will get corresponding to omega tends to infinity. So these are the basic 4 step. And then after that, after getting preparing this table, you'll get the various points between starting and ending point, so you can plot the polar plot. Okay, then we will determine how to determine stability from the polar plot. Okay, so we just sketch one example how to plot a polar plot. Then we can determine how to determine stability from the polar plot. Okay, so take down one example. I can tell you the shortcut how to identify starting point and ending point of your polar plot. Rough sketch you will get. Okay, so sometimes question may be asked in the GATE examination also. Write down problem 1. Draw the polar plot for G of S is equal to 1 upon 1 plus ES. Okay, so let's say value of T is equal to 1. So here you are getting G of S is equal to 1 upon 1 plus S. Okay, so what are the steps I have told you while constructing the polar plot? So S will be replaced by J omega. Okay, so write down the solution. So here S will be replaced by J omega. So S will be replaced by J omega. So G of J omega is equal to 1 upon 1 plus J omega. Then in the second step, find the value of M and phi by using G of J omega into H of J omega. Okay, then magnitude, so capital M is given by magnitude of G of J omega. What is the magnitude of this term? 1 upon 1 plus J omega. So it will be given by 1 upon square root of 1 plus omega square. This is the magnitude. And angle phi is the angle of G of J omega. So what is the angle? So 1 का एंगल रहेगा 90 डिग्री और 0 डिग्री. ओके, सो देयरफॉर इसको लिखेंगे 0 एंगल 0 अपॉन 1 प्लस जी ओमेगा. तो इसका एंगल रहेगा tan inverse of imaginary part upon real part. So this will be imaginary part, this could be real part. So imaginary upon real, so imaginary part is omega by 1. तो ये अगर tan inverse ऊपर जाएगा तो आ जाएगा minus tan inverse of omega. So this is the expression for phi, the expression for. Okay, then prepare a table. First value you can take omega, second value is m, that is equal to magnitude of G of J omega. Then third value is angle phi, that is angle of G of J omega. Then your starting point always start at omega is equal to 0. Okay, so simply substitute omega is equal to 0 in this m. Okay, so 1 square root of 1 plus 0, so it could be 1. Then substitute omega is equal to 0. What is tan inverse of 0? We have calculator. Can you tell me the value? It could be 0. Okay, so this will be the starting point. So you can write down here. This could be the starting point. Then ending point you can directly find. So when omega equals to infinity, you can find the end point. So when you substitute omega is equal to infinity, so 1 by infinity is 0. Okay, and then angle, can you find tan inverse of infinity? What will be the value? It could be 90 degree. Okay, so these are the starting and ending points. Then intermediate omega value, you can consider any value. Say I can consider 1, 5, 6, 10, like this. So randomly you can choose the value and complete this table. So for 1, I will get 0.707 magnitude, angle is -45. For 5, I will get 0.16 and angle is -72 degree, like this. Okay, so that much value I have determined. So in this way we have completed the table, and after completing this table you can sketch the polar plot. Okay, then what is polar plot? You can sketch this plot on graph paper also by selecting the scales. This will be real axis, this will be imaginary axis. So locate the starting point first. So starting point is magnitude is 1 and phase angle is 0. So here is where you can locate this point. You can remember this diagram. This circle indicates what? This concentric circle indicates. Concentric circle क्या indicate करते हैं? This indicate magnitude. Okay, and this line indicates the phase. Okay, so magnitude कितनी है? 1. Okay, so therefore you just draw. So here, somewhere here, this is my 1 magnitude, unity value +1. So this value is +1. And what is the phase? Phase कितना है उसके corresponding? अगर मैं यहाँ पर unity magnitude का circle draw कर रहा हूँ, the magnitude of this my circle is unity. So where is the exact location of my this point? तो मैग्नीट्यूड तो वह पॉइंट कहीं पर भी ले लूंगा, लेकिन मेरा फेज कहां पर है? my phase angle phi is 0. So phi is 0 corresponding to this real axis. So this is the value of line corresponding to that phi is equal to 0. Okay, so therefore this is my first point. So this will be our starting point. So you just note down, this will be the starting point. Please do it. यहाँ तक किसी को डाउट है? Yes. Okay, I hope everybody have located this point. So starting point we have located. Then you can directly locate the ending point. So where is the location of ending point? Here magnitude is 0. So magnitude 0, that means this is the point. और angle कितना है? It could be -90. Okay, so therefore आपका ये point रहेगा एंगल माइनस दिस विल बी, यहाँ से मेजर करोगे तो प्लस क्लॉकवाइज एंगल, तो यहाँ पर आप नोट कर लीजिए क्लॉकवाइज एंगल is negative and anti-clockwise angle from reference is always positive. So therefore we can measure in and clockwise direction, it is minus 90. तो यहाँ जाएगा minus 90. Okay, so ये हो गया आपका ending point. So this will be end point of your polar plot. Then intermediate point you can plot 0.707. ये 0.1 है, तो यहाँ पर कुछ तो भी 0.707 का सर्कल आएगा. ओके, और उसका एंगल है -45. तो ड्रॉ द लाइन करस्पॉन्डिंग टू -45. दिस एंगल इज -45. so here is the intersection, this will be your second point. Then 5 के corresponding -72. draw the line of -72. okay, and the magnitude of 0.16, so somewhere here like this will be our 4 points. So now you can join this. So start from starting point and end. So this will be your rough nature of polar plot. This will be starting point, this will be second point, this will be third point, and this will be fourth point. So here, like this. To give the figure for polar plot of given example. So similarly, you can take down another example. G of S equal to 100 upon S plus 2, S plus 4, and S plus 8. Plot the polar plot. What is the first step? Write down the solution. S will be replaced by j omega. So g of j omega equal to 100 upon j omega plus 2, j omega plus 4, j omega plus 8. Then find m, magnitude of j omega. It will be given by 100 upon, तो ये आएगा आपका अंडर रूट ऑफ 2 स्क्वायर प्लस ओमेगा स्क्वायर और ओमेगा स्क्वायर प्लस 2 स्क्वायर मल्टीप्लाई बाय अंडर रूट ऑफ 4 स्क्वायर प्लस ओमेगा स्क्वायर मल्टीप्लाई बाय ओमेगा स्क्वायर प्लस 8 स्क्वायर. So this is our magnitude m. Then similarly find phi. Tell me the phi expression. I will be given by angle of g omega. Okay, so I will be given by, तो 100 at an angle, 100 का एंगल आ जाएगा 0. ओके, तो 100 का एंगल आ जाएगा एंगल 0 डिवाइडेड बाय एंगल ऑफ दिस j omega plus 2, रियल पार्ट, इमेजिनरी पार्ट ऑफ tan inverse of imaginary upon real. So tan inverse of omega by 2 plus second term का angle tan inverse of omega by 4, tan inverse of omega by 4, and third tan inverse of omega by 8, tan inverse of omega by 8. So we'll get the expression for phi as ये न्यूमरेटर में जाएंगे तो माइनस tan inverse of omega by 2 minus tan inverse of omega by 4 minus tan inverse of omega by 8. This is the required expression for phi. This is for m. So the equation 1 and equation 2. So from equation 1 and 2, you can prepare a table. That is, first column is omega, second one is m, third one is phi. So starting point omega is equal to 0, ending point omega is equal to infinity. So substitute omega is equal to 0 in this term and find m. So tell me the value of m at omega is equal to 0. Please substitute the values in the calculator and tell me the value of m. So m is 0. Sorry, m is 1.56 and angle is 0. Then last value, when you substitute omega is equal to infinity, you will get magnitude 0 and angle minus 270. Similarly, intermediate value I have taken directly 5, then 10. Okay, so 5 के corresponding मिला है 0.30, angle is minus 151.54. 10 के corresponding आता है 0.07, 198.22. So this is the table. So now sketch the polar plot from this table. This is the real part, will be imaginary axis. So locate the starting point. Omega is equal to 0, 1.56, magnitude 0. So somewhere here, let's say this magnitude is 1.56 and angle is 0. So this will be my starting point. Then the ending point, omega is equal to infinity, magnitude is 0. That means this point is located here and angle is minus 270. Minus 270. Okay, so क्लॉकवाइज से मेजर करो लाइक दिस. यहाँ से ये होगा minus 90, minus 180, minus 270 here. So that means in this way, through this angle, it may terminate. Then locate the point 5. So 5 के corresponding angle है minus 151. So 90, here is 180, here somewhere here minus 151.54. Magnitude is 0.30 here like this. I can locate this point. Then second 10 के corresponding 0.07, 198, 180. Somewhere here आ जाएगा. Here somewhere. Here this angle is 198 point something. Okay. So now you can draw the polar plot starting here and join these 2 points. And through 270, it may terminate on. So this angle is 270. Okay. So this is the figure for polar plot. polar plot of given example. Okay. So in general, how is the nature of your starting of your polar plot? So you just remember this structure. You will get a rough sketch. So while solving the examples in the gate, it will be useful to you. So type 0 system, here is type 1, type 2 and type 3. ओके और ये जो क्वाड्रेंट है इसमें आएगा आपका ऑर्डर 1, हियर इज ऑर्डर 2, order 3 and order 4. So you see this in this example, what will be the type of the system? S plus 2, S plus 4, S plus 8. So it could be type 0 system, S raised to power n कोई है नहीं. So type 0 system, therefore your graph will be start from here type 0. Okay. And then what will be the order of the system? S into S, S square, and S square into S, S cube. That means it could be ordered 3. Okay, so type 0, order 3. So that means your nature of the plot could be like this. So in this way, you can sketch a rough sketch of your polar plot by using this structure, type 0, order 3. Okay, so if you take example, previous example, again you will get type 0. What is the previous example we have taken? 1 upon 1 plus S. So again it is type 0 and order 1. Okay, so therefore type 0, order 1. So order 1 this. So therefore previous graph could be like this. So you can easily sketch a polar plot by using this. Please remember. Okay. Then we'll discuss about how to determine a stability from the polar plot. Okay, so which is very, very important. Omega GC and omega PC, how to determine from the polar plot. Okay, so please understood this. This is very, very important. First, give the heading gain margin. That is GM. How to determine gain margin from the polar plot. Okay. So gain margin and phase margin, these are the two measures of measuring relative stability. Okay. So you just sketch these two figures so that it will be, you can understood this. So these two figures are very, very important to understood the concept of gain margin and phase margin from the polar plot. Okay, so draw unit circle. So this magnitude is -1. Here is +1, 1, 1. Okay. Similarly here, -1, 1, 1, minus. Okay. Then so we just give the name to this is unit circle. Okay. Then let's say this will be the nature of your polar plot. If the nature of polar plot could be like this, okay. So this is at omega is equal to infinity, and this is the starting point, that is omega is equal to 0. And in the second figure, we will consider the polar plot like this. This is at omega is equal to 0, and here omega is equal to infinity. Okay. Then so here this is unit circle. So here in figure A, we just give figure A and figure B name to these two figures. Okay. So in this figure A, this polar plot intersect this unit circle at this point. Okay. So I may consider this point is P. Okay. Then the value of omega corresponding to this point, value of omega corresponding to this point, that is called as omega PC. Okay. So sorry, omega GC. So omega GC is nothing but a gain crossover frequency. Gain crossover frequency. And second term is related with omega PC is nothing but a phase crossover frequency. Phase crossover frequency. Okay, so these are the two important terms. So here in this case, omega is equal to omega GC, which is located by P point. Okay, and again this polar plot intersect this negative real axis at this point, and this point I may denote it by capital Q. Okay, so for this point, the value of omega, which is called as omega PC. Okay, so omega equal to omega PC is the point where your polar plot intersect the negative real axis. Okay, and omega is equal to omega GC is a point where your polar plot intersect the unit circle. So the corresponding point is called as gain crossover frequency, and the point at which polar plot intersect the negative real axis. So the frequency corresponding to that point is called as phase crossover frequency. Okay, then ये हो गया omega GC and omega PC location. So similarly, you can locate the omega GC and omega PC in figure B. Okay, so in figure B, this is the point. So this will be your capital Q. तो इसके corresponding आपको मिलेगा capital Q नेगेटिव रियल एक्सिस को क्रॉस कर रहा है. So omega is equal to omega PC, और यहाँ पर यूनिट सर्कल क्रॉस कर रहा है. So therefore this is the point corresponding to omega is equal to omega GC. Okay, Then where is the location of phase margin and phase margin? Okay, so you just join this origin point to this unit circle where your polar plot intersect to unit circle. So here you just join this line. So this value indicates the phase margin. So this will be your phase margin. Okay, and for figure A, the value of phase margin is positive. Okay, and the value of omega GC is less than omega PC. So therefore, your system become stable one. So we can comment later on the stability. Okay. Then for this figure, you just join. So here we have joined. So this angle is nothing but your phase margin above of negative real axis. So here in this case, phase margin is negative, and here omega GC value is greater than omega PC value. Okay. So these are the basis for determination of phase margin and gain margin. Okay, so how to determine gain margin and phase margin? So phase margin we have already shown in the diagram. So when you draw a polar plot on the graph paper, you can directly measure it, or with the help of formula we can calculate it. Okay, so for just note down the formula is for gain margin. How to determine gain margin? Okay, so find the point where gain margin is nothing but find the point where polar plot crosses -180 degree line, that is negative real axis, negative real axis. Okay, the value of omega at that point is omega is equal to omega PC. Okay, so therefore the magnitude of G of J omega at omega is equal to omega PC. Okay, so therefore gain margin is equal to 1 upon magnitude of G of J omega at omega is equal to omega PC. Then sometimes gain margin is given in decibels, so it will be given by 20 log 10 of 1 upon G of J omega. So this is the expression for gain margin. So gain margin, you just substitute omega is equal to omega PC in magnitude of G of J omega. So 1 upon G of J omega, that will give you gain margin, and 20 log of this value, that will give you gain margin in E. Okay, so at omega is equal to omega PC. So at omega is equal to omega PC, your polar plot crosses the minus 180 degree line. So we have to find the value of omega corresponding to. Okay, so that you can easily find from the table also. I can tell you while solving the problem. So this is the basic definition of gain margin. Then second thing is the phase margin. So phase margin you can directly measure from the polar plot, but for that purpose you have to draw the polar plot on the graph paper. Okay. So if you have not drawn a polar plot on graph paper, then we have to determine the phase margin by analytical method. Okay, so you just write down the steps to determine the phase margin. Okay, so in order to determine phase margin, first of all, we have marked a unit circle, that is critical point -1, 0. Okay, so mark the point -1, 0, that is critical point with origin as a center. Okay, then find the value of omega equal to omega GC. So omega GC is the point where your polar plot intersect unit circle. This is also called as unit circle. Okay, then so from this plot omega is equal to omega GC, you will get जो पॉइंट के यहाँ पर आपका पोलर प्लॉट इंटरसेक्ट करेगा यूनिट सर्कल को corresponding this value of omega is called as omega GC. So once you get omega GC, okay, then measure the phase angle between 180 and above point. Then write down the next step. Measure the phase angle. ये phase angle आपको measure करना है, ये 180 degree line and above. Measure the phase angle between 180 and above point. Okay, sometimes ये negative से ऊपर रहेगा, sometimes below रहेगा. Okay, so how to decide PM is positive or negative? So phase margin is positive for which case? When the polar plot is below negative real axis, you see this polar plot or this omega GC value is below negative real axis, therefore the PM is positive, and PM is negative exactly opposite. PM is negative when polar plot is above the real axis, negative real axis, above the negative real axis. So होगा PM positive and PM negative. Okay. Then last point regarding phase margin and gain margin. If the curve does not cross unit circle, if the curve does not cross the unit circle, then phase margin is infinity, and similarly, when the curve does not cross minus 180 degree line for finite omega, then gain margin equal to infinity. So that we will see while solving the problem. Okay. Then write down the last important point. So formula of gain margin is given by 1 upon absolute of G of J omega into H of J omega at omega is equal to omega PC. Okay. And for phase margin, the analytical formula is 180 plus angle of G of J omega into H of J omega at omega is equal to omega G. Okay. Then conclusion number 1, when omega GC is less than omega PC, at that time your phase margin is positive, gain margin is also positive, therefore your system is stable. Then second condition will arise like this: when omega GC is greater than omega PC, at that time phase margin is negative, gain margin is also negative, so therefore system is unstable. And third category, third possibility, omega GC is equal to omega PC. So here in this case, phase margin is equal to gain margin is equal to 0. So this term is marginally stable. So please note down this stability information. So with the help of these two diagram, we can easily determine omega GC, omega PC, gain margin and phase margin. So formula of gain margin is this: 1 upon magnitude of J of J omega into H of J omega at omega is equal to omega PC. Phase margin is 180 plus angle of J of J omega into H of J omega at omega is equal to omega. Here omega PC is gain crossover frequency and omega PC is phase crossover frequency. Okay. So in the next lecture, we are going to solve the problems based on this polar plot. Okay. So please note down this information. So today we stop here. Hello, Rohan. Rohan Passport. Are you there? Hello. So whether tomorrow you will have an extra class at 9 a.m. of other subject?
No, sir.
है क्या? है या नहीं है?